Good morning, boys. I hope you all have done the exercise 1.1 and I have given some of the concepts regarding relations, and that is also posted. You can see it, and I hope that you all have done the exercise 1.1. And today I am going to start with the definition of the function. By the way, we have learned it in class 11th, but I think it is better to revise once more. Suppose we have two non-empty sets A and B. Now, A has the elements 1, 2, 3 and 4. B has the elements suppose 1, 4, 9 and 16. Now, we apply a rule F on A such that the F image of 1 is 1, F image of 2 is 4, F image of 3 is 9, F image of 4 is 16. That means F of 1 is 1, F of 2 is equal to 4, F of 3 is equal to 9 and F of 4 is equal to 16. F is a rule which is applied on the elements of set A, which gives the elements of set B. That is, for each and every elements of A, there is a unique element in the set of B. Then this function is defined. Function is a rule. Function is a rule which implies that on the elements of A, and it gives the image in the set of B, right? Also, I would like to just remind you, all the elements of this set is called domain, and all the elements of set B is called codomain, right? One more thing, these are also known as the pre-image, and this is also known as the image. In both the way we have to, F image of 1 is 1, F image of 2 is 4, F image of 3 is 9, F image of 4 is 16, and the pre-image of 16 is 4, pre-image of 4 is 2, pre-image of 9 is 3, like that, right? When codomain, domain, pre-image and image, please remember these terms. And now for the definition of functions, we can concise that F is a rule which is applied on the elements of A, so that for each and every element of A, we get a unique image in the domain of B. Then we say that the function is defined, right? Now I will give you some examples where the function is not defined. For example, suppose if I write A and B, F is a rule, here 1, minus 1, 2, minus 2. Now see, this image is 1 and 2 and minus 2 are left out here. Now here there are two elements in set A whose image is not present in B. It means it is not a function. ये function नहीं है. This is not a function. Now suppose the third example if I take. Here we have A, here we have B, 1, minus 1, 2. Now image of 1 is 1 and image of 1 is, suppose if I am taking now 1, or I can take 3. Now image of 1 is 1 and image of 1 is 3. This is also not a function. What is the rule? For each and every element of A, there exists a unique element in the set of B. See, 1 minus 1 has the image 1. but there are two elements in set A having no image in the set B. That's why it is not a function. But if I remove this, then it will be a function. Then it will become a function. Now it is a function. Because f of 1 is 1 and f of minus 1 is 1. This is function. But this is many one function. Here 1 has two images, 1 and f of 1 is also 3. That's why it is not a function. If I write here now 3, tell me now. This 3 doesn't have any image in B, and that's why this is not a function. A function nahi hai. We cannot have any elements in A whose image is not present in B. But on the other hand, we can have some elements in B whose pre-image is not present. This is possible. That's why sometimes I discuss this function like the mirror image. This is the one mirror, this is another mirror. If we see all the objects in this mirror, you can see in this mirror. And in this mirror, when you see the image, we can find out the other element which is not present in this mirror, which is just outside, left side or right side, something which we can see in this. That's why we can have some elements, we can have some members in this set of B whose pre-image is not present. This is possible. But each and every element of set A must have their image in set of B. Then it will be a function. Right? Now, the second thing I will discuss, the type of function. Type of function. A and B. Now see, if I write 1, 2, 3 and 4, x, y, z, w. F is a rule applied from the set A to set B. 1 has the image x, 2, y, 3, z, 4, w. For each and every element of set A has unique image in the set of B. That's why it is a 1-1 function. Not only 1-1, this is also onto function. For the onto function, whenever you are asked to check whether it is onto or not, for the onto you have to check, is there any element in B whose pre-image is not present? Because if I write here suppose m, I can write it is also a function, but it is not onto, it is an into function. Right now it is a into function because m is here whose pre-image is not present in A. That's why it is 1-1 into function. Right? But if I remove this m, then it becomes 1-1 onto function. 1-1 onto function. Right? Now, see there is an example. If I write here now 1 minus 1, and here I write here also 1. F rule applied from A to B. 1 has image 1. Right. This is now what? Many one. Many one, because at least there are two elements in set A. There are two elements in set A having same image in set of B. That's why it is many one. And there is no element in B whose pre-image is not present. That's why it is what? Many one onto function. Many one onto function. Right? Now, if I write here A, B, rule F applied on this, right? And here suppose we write 1, 2, 3, x, y, z, right? 1, 2, 3, and if I write here now m, this is what? 1, 1, 1, 1 into function. 1, 1 into function. Right? 1, 1 into function. Why into function? Because at least there is one element in B whose pre-image is not present. That's why it is 1, 1 into. This is 1, 1 onto. Many one onto. Now I will give you another example of many one A to B, 1 to x, right? Many one, and if I write here y. This is what? Many one into function. many one into function. Many one into function. Right? See now. 1 1 onto 1 1 into 1 1 onto function, many one onto function, 1 1 into function, and many one into function. Is it clear now? Fine. Now I will just make you to write the definition of the function. Right. If f is a function from a to b, or f is a rule from a to b, then the set f also set of pre-image is domain of function f, and set b, then the set a also set of pre-image is domain of f, and the set b is called codomain of function f. And for each and every element of set A, if there exists a unique image in the codomain of f, then f is called a function from A to B, and it is denoted as f is a function from A to B. Remember that also range is the subset of codomain. Please note down this point. Range is the subset of codomain. Right? This is the definition of the function. And I think it is clear for you that what is domain, what is codomain, and by the figure which I have discussed. Fine. Now I will discuss about the definition of 1 1 of injective function. So another name of 1 1 is injective function. A function f from A to B is said to be 1 1 if every distinct element of A have a different image in B under given condition f. That is, x1 is not equal to x2 implies that f of x1 is not equal to f of x2 for every x1 x2 belongs to A, or x1 is equal to x2 implies that f of x1 is equal to f of x2 for every x1 comma x2 belongs to A. With the figure I can say this is now 1 1 I am talking now. This is function A, this is function B, rule f. Now for 1, 2, 3 I have here image 1, 4 and 9. Image of 1 is 1, 2 is 4 and 3 is 9. I think if you remember, this is 1 1 on 2. Why on 2? Because there is no element in B whose pre-image is not present in A. That's why it is 1 1 on 2 functions. But right now I am discussing only 1 1, which is also known as injective function. Another name of this 1 1 is injective function. And that's why, see, if 1 and 2 are not equal, then their f image are also not equal. And if 1 and 2 are equal, then their f image will be also equal. 1 is equal to 1, 1 is equal to 1, therefore f of 1 and f of 1 will be also equal. That's why these two lines you have to remember while we have to prove, you check whether the given function is 1 1 or not, then you have to have very clear concept of this part. Yes, for any given function you will be given and you are asked to find out whether this function is 1 1 or not. In that case you will use this concept. I think it is clear. And now I will discuss the second part of the function. Right. Now on to function which has another name, that is called surjective function. Now a function f from a to b is said to be onto function if this I double f, if and only if, in short we can write I double f, if and only if each element of b is the image of some elements of a under f. For example, whenever you have to check the function is onto, then 1, 2, 3, 1, 4, 9. F image of 1 is 1, F image of 2 is 4, F image of 3 is 9. And you have to check what have you done. Each an element of B, 1 has the image, pre-image is 1, 4 has the pre-image 2, 9 has the pre-image 3, and there is no element in B. There is no elements in B whose pre-image is not present in A. Here I have written now each element of B is the image of some elements of A under F, and there is no elements in B whose pre-image is not present in the domain of A, and that's why it is a what? Onto function. Onto function has another name, and that is called what? Surjective function. Right? Now I will discuss one function I have discussed, one onto discussed, many one onto function discussed, and many one into function discussed. Actually in class 12th we have to deal mostly with this one function, onto function, and the function which is one and onto, its only inverse function we can have. But before I go and define the inverse function, it's better to discuss the composition of two functions. Right? So now I will discuss the composition of two functions. Composition of two functions. Let f is a function from a to b and g is a function from b to c. Then composition of two functions f and g is denoted as GOF of x. Right? That means GOF is a function, a composition of two functions, right, is equal to G of f of x. That means denoted as, and GOF is a function from A to C. A to C. I'll make it with the help of figure A, B and C. Set A, set B and set C. F is a function from A to B. G is a function from B to C. You know that. If I write here x, here I get the elements. When I apply this rule f on x, I'll get here f of x. Now we apply the rule g on the elements of b, that is here becomes now g of f of x. That's why the composition of the function from a to c, g of f is the composition of two functions which is from a to c, and it is defined as g of f of x is equal to g of f of x. Right? If I take another example, right, if I take here 1, if I take here 2, if I write here 3, and now if I ask to find the g of f of 1, you find out. Because see now, g of f of 1, we have written g of f of x is equal to g of f of x. So now g of, according to definition, g of f of 1 is equal to g of f of 1, and g of f of 1 is how much? F of 1 is 2, f image of 1 is 2, I write here 2, and g image of 2 is how much? 3. That's the answer is here 3. Now g of f of 1 is 3. In this way, we combine the two functions f and g. If I have to write FOG, here I can GOF. I can write F to G also. Now FOG will be a function from C to A. From C to A. Right? This is the composition of two functions. How to combine these two functions. And now I will discuss the inverse function. Right. Now the invertible function. First of all, make it sure that a functions can be invertible. That means f is a function from A to B. F is a function from A to B. G is a function from B to A. Two function. Let f is a function from A to B. If there exists a function g from B to A such that GOF is equal to IA and FOG is equal to IB. Invertible function, then f is called an invertible function. That is, for being an invertible function, it is very, very important. First thing, that the function must be 1, 1 and onto. If the function is not 1, 1 and onto, then its invertible function is not defined. That's why make it very, very sure that first of all, whenever you are asked to prove that it inverse exists or not, and so that it is an invertible function, then first of all you have to prove it is 1, 1 and onto, and then we can find out their inverse function. That's why GOF is equal to IA and FOG is equal to IB, right? Where IA and IB are the invertible function, are the identity function. Then f is called an invertible function and g is called the inverse of f. That means f inverse is equal to g. See, if I write here x, here what will get? F of x. Simply, sometimes we write y is equal to f of x. Yes or no? Right. Now the inverse of this, I write f inverse of y is equal to what? X. F inverse of y is equal to x. Right. F is a function from A to B. G is a function from B to A. That's what we got now. G is equal to f inverse of y. That also very, very important point. Note it. This point. Got it? This was the concept regarding the function. And now we'll discuss the questions of the exercise 1.2, which is based on the function. Right? Thank you very much for the today's lesson. And just one thing I would like to remind you, please go through the concept which is given in your NCERT book also, so that while you are solving the problems, it will be easy for you. By the way, in the next lesson, I will discuss the problems of exercise 1.2, and I hope that you all have done the problems of 1.1. If you have not done, please do it in your rough notebook, fair notebook, so that when you are here, we can check it and I can check it. If you have any difficulty, you are free to ask. By the way, in the next lesson, I will discuss the second exercise 1.2 with the problems related to the function. Thank you very much.